Hello, let us see the construction of LR0 items. So in this problem we are given a grammar which is E produces E plus T and E produces T, then T produces T star F and T produces F, then F produces this production rule, and finally F produces ID. So we have to consider the construct the LR0 items of this given grammar. Now this grammar will be augmented. So first of all we have to create the augmentation of this grammar. So augmented grammar. So what is augmented grammar? Just append a new production rule, E dash produces E, and the rest of the production rule will be copied. So this is an augmented grammar. Now will we consider the construction of LR0 item. So this is the first production rule, assuming that E dash is the start symbol. Now we have to construct the LR0 items. So it is nothing but the calculation of closure of E dash produces dot E. So the set of this function is called the LR0 items. Now the closure will contains this production rule also. So the first item will be E produces dot E. Now the dot is to the left of this terminal E, so write all the production rule which starts with E. So as dot is to the left of E, so all this production starting with E will have dot to the left. So first one will be this and dot T. So considering this production rule is done, now consider this production rule. In this production rule the dot is to the left of E, so write all the production rule that starts with E. If we do that, we will be again considering the same set of production rule. So it will be again dot E plus T and dot T. So these two are already computed here, so we do not need to consider this E again. Now consider this production rule. Here the dot is to the right of T, so this is a new one. So write all the production rule that start with T. So this this production will have dot to the left of T, and the second one will also have dot to the left of F. Now here consider this production rule. Here dot is to the left of T, but the T is already considered. Now consider this production rule. Here the dot is to the left of F. F is a new one, so write all the production rule start which has F to the head or to the right of the production rule has F. Now this will also have this. Now if we see this production rule, it does not have dot to the left of any variable or non-terminal. So here for this production rule closure cannot be computed, and with the same reason F produces dot ID will not have any closure. So this is the closure of E dash produces dot E. Now let us try to compute the closure of for example T produces T dot star F. Now the closure will contains at least this production rule. Now from here try to find, is there any production rule which has dot to the left of any non-terminal? No. So the closure of this will be only this single item. Now let us try to calculate the closure of E produces E plus T dot T. Now the closure of this will be at least E produces plus dot E. Now consider this production rule. Is there any production rule which contains dot to the left of any variable? Yes. So it will have another set of production rules. So write all the production rule that starts with T. So there are two such production. Now all the production that starts with t will have dot to the left, so this will have dot to the left, and again this t will have dot to the left. Now consider this production rule. In this production rule, the dot is to the left of t, and the variable t is already considered, so we do not need to consider this production rule. Now consider this production rule. This production rule has dot to the left of a variable f which is not included, so let us compute the closure of this production rule. So write all the production rule that starts with f. So now here the dot is not to the left of any variable. Here the dot is to the left of a terminal, so we should not include this one. Now consider this production rule. This is also not considered, as dot is to the left of a terminal. So closure of E produces E plus dot T will be this set of production rule. Now let us again see closure calculation of for example, E produces T dot. Now this will contain as this one. Now there is no such production rule which has dot to the left of any variable, so this will contain only this production rule, and this kind of states are called the terminal states, because this states contains a reduction. This is a reduction. Now let us compute closure of, for example, E f produces this one, so we have to calculate the closure of this. So it will be f produces. Now here the dot is to the left of E, so let us include all the production rule which starts with E. So it will be E plus T, then dot T. Now consider this production rule. In this production rule, the dot is to the left of E, and E is already considered. Now consider this production rule. This production rule has dot to the left of T, and T is not considered, so write all the production rule starts with T. So it will be and dot F. Now if you consider this production rule has dot to the left of T, and T is already considered, so this will not be considered. Now consider this production rule. This production rule has dot to the left of F, and F is not considered, so we'll write all the production rules starting with F. So it will be this one and this one. So this is the set of all items of this particular closure. Thank you.